Welcome, everyone. My name is Melinda Shelby. I'm a member of the clinical team at Aegis Sciences Corporation, and today I will be presenting the 2025 mid-year update on NPS trends. The following material is not authorized for reproduction without express written consent. Thank you for joining us for today's webinar. This is a brief educational webinar examining detection of NPS at Aegis Sciences Corporation in Q1 and Q2 of 2025. From this presentation, participants will be able to identify various classes of NPS and the most prevalent NPS identified for each class. Participants will also be able to identify trends in NPS detection. Those who missed the live presentation or would like to hear it again may find a recording of this presentation on the Aegis website at www.aegislabs.com. New or novel psychoactive substances, also called NPS, are a diverse group of synthetic substances created to mimic the effects of prescription or illicit drugs that are often used non-medically. There are various classes of NPS, including designer opioids, designer benzodiazepines, synthetic cannabinoids, synthetic stimulants, hallucinogens and dissociatives, and others. NPS may change frequently as legislation to control specific chemical structures or classes of NPS is introduced. Once an NPS has been deemed a controlled substance, often new or modified, non-regulated NPS appear. This remains a challenge for regulatory and enforcement agencies, monitoring institutions, clinical and toxicology laboratories, as well as healthcare providers. Aegis offers NPS testing by class in both urine and oral fluid. Shown here are 2025 NPS order rates by class and by quarter. Of the total number of samples with any NPS class ordered, designer opioids class was the most frequently ordered at approximately 95%, followed closely by designer benzodiazepines at approximately 90%. The NPS other class was the next most frequently ordered class at approximately 76% of samples with any NPS class ordered. Order rates for synthetic cannabinoids and synthetic stimulants were similar, ranging from 61 to 63%. The hallucinogens and dissociatives class was the least frequently ordered class at a rate of roughly 40% of samples with any NPS ordered. Order rates remained similar between Q1 and Q2 for all classes. When evaluating NPS data, it's important to consider that order rates may impact NPS detection and observed prevalence between classes. The data in this clinical update are presented by drug or metabolite as proportion of NPS detected in a given class per quarter. Trends were then evaluated by looking at percent change in proportion from Q1 to Q2. This figure shows the proportion of each compound detected in the NPS other class by quarter. The NPS other category includes compounds that do not easily fit within other designated NPS classifications. Not all compounds in this class are specifically NPS. Some are veterinary medications or other substances that have been identified as adulterants in the illicit drug supply. For example, xylazine is approved for use in veterinary medicine as a sedative with analgesic and muscle relaxant properties. However, it is not approved for use in humans and may cause unique withdrawal episodes and severe necrotic skin ulcers. The U.S. FDA previously released an alert regarding risk to patients exposed to xylazine in the illicit drug supply. Now, in both Q1 and Q2 of 2025, xylazine and its metabolite 4-hydroxyxylazine, shown in blue, made up the largest proportion of compounds detected in this class. This is not surprising, as in 2023, xylazine became the most prevalent NPS detected at Aegis, irrespective of NPS class, and it has remained so through 2024 and the first half of 2025. In Q1, xylazine and its metabolite represented approximately 70% of compounds detected in the NPS other class. However, this proportion decreased in Q2. Medetomidine and its metabolite 3-hydroxymedetomidine, shown in lilac, were the next most prevalent compounds in the NPS other class in both Q1 and Q2. Recently, it has been reported to be rapidly proliferating across the United States. So in Q1, the prevalence of tianeptine metabolite, MC5, shown in green, phenibut in hot pink, and the emerging adulterant BTMPS in purple was nearly identical. In Q2, the proportions of tianeptine and phenibut increased, whereas the proportion of BTMPS decreased slightly. Now, phenobutazone and its metabolite oxyphenbutazone, shown in shades of orange, were added to Aegis NPS other testing in December of 2024. And phenylbutazone was removed from the market due to severe adverse effects, but it has been identified as an adulterant in the illicit drug supply. Now, you may be able to notice the very small sliver of orange in Q2, but it's really too small to be visible in Q1. And lastly, we have etomidate, which is shown in light blue. It was just added to testing in June of 2025. So the results for etomidate are really only for 1 month. It is a sedative hypnotic drug that is used in critical care and emergency medicine, but it has recently been detected in the illicit drug supply. Shown on the left is the percent change in proportion of NPS other compounds from Q1 to Q2. The total number of detections in the first half of 2025 is shown in parentheses. An inset of the prior pie charts is included to aid in visualization. As mentioned previously, the proportion of xylazine and metabolites shown in blue decreased from Q1 to Q2, mostly due to a change in proportion of metabolite, which saw a 40% decrease. The only other compound in this class which saw a decrease in proportion was BTMPS, which is shown in purple, and decreased by 6% from Q1 to Q2. Other compounds in the NPS other class saw increases in proportion from Q1 to Q2, including medetomidine and its metabolite shown in lilac, which increased roughly 30%, and tianeptine and its metabolite shown in shades of green, which increased roughly 40%. Now, the proportion of phenibut in Q2 increased to 88% from Q1, and phenibut ended up having a higher overall prevalence for the first half of 2025 at 505 positives than did tianeptine with 465 unique positive specimens, thus making phenibut the third most prevalent NPS in this class, followed closely by tianeptine. Now, although the percent change in the proportion of oxyphenbutazone between Q1 and Q2 is substantial, it should be interpreted with caution as its proportion in Q1 is too small to even be visualized, and the prevalence overall in 2025 is low. This figure shows the proportion of designer opioids detected in Q1 and Q2 of 2025. Designer opioids with less than 5 detections in the first half of 2025 were excluded. Fluorofentanyl and related compounds, dispropionyl fluorofentanyl and fluoronorfentanyl, together represent approximately 59% of the proportion of designer opioids detected in Q1. Now, for multiple years, fluorofentanyl was the most frequently detected NPS at Aegis among all NPS classes. However, in 2023, it was overtaken by xylazine. And since then, it has remained the second most prevalent NPS detected at Aegis, irrespective of NPS class. So looking at the 2025 Q1 data, the second largest proportion of designer opioids was for orthomethylfentanyl or O-methylfentanyl and its metabolite, and they are shown in purple. And the third largest proportion was for despropionyl metaparamethylfentanyl, shown in lilac. So methylfentanyl has 3 positional isomers, ortho, meta, and para, and they were added to Aegis designer opioid testing in December of 2024. And in our testing, the ortho isomer is distinguished from meta and para isomers. In Q1 of 2025, the proportion of N-desethyl metanidazine, which is shown in teal, was similar to that of despropionyl metaparamethylfentanyl, shown in lilac, but their trends in proportion from Q1 to Q2 were opposite. Now, some of the larger, more noticeable differences in proportion between Q1 and Q2 include increases in despropionyl metaparamethylfentanyl, shown in lilac, norcarfentanil in hot pink, acrylfentanyl in orange, and decreases in valeriylfentanyl carboxymetabolite in green, and nitazene and nitazene analogs shown in shades of teal and brown, respectively. Now, on the left is shown the percent change in proportion of designer opioids from Q1 to Q2, along with the total number of detections in the first half of 2025 in parentheses. The proportion of fluorofentanyl and related compounds in Q2 is similar to Q1, but with an approximate decrease of 13% in metabolite fluoronorfentanyl. Some of the more obvious changes in proportion from Q1 to Q2 included increases in despropionyl metaparamethylfentanyl in lilac, which increased by 109%, norcarfentanil in hot pink, which increased by 121%, acrylfentanyl in orange, which increased by 164%, as well as fentanyl carboxymetabolite in green, which decreased by 83%, and nitazene analogs shown in teal, with the exception of N-diethyl N-nitazene and protonitazene, decreased between 40 and 77%. And imperoladinonitazene analogs in shades of brown decreased between 65 and 80%. Now, percent changes in the proportion of despropionyl chlorofentanyl, which is showing a 200% increase, and protonitazene and brorphine, which both show a 433% increase, seem quite large, yet those changes are less noticeable in the pie charts because the total number of positives for the quarter is quite small, with protonitazene and brorphine each having 7 detections for the first half of 2025. This figure shows the proportion of designer benzodiazepines detected in Q1 and Q2 of 2025. Designer benzodiazepines with less than 5 detections in the first half of 2025 were excluded, except for bromazepam, as was included along with its 2 metabolites that have a greater positivity. Now, bromazolam and its metabolite alpha hydroxybromazolam, shown in blue, were approximately 72% of all designer benzodiazepines detected in Q1 of 2025. Now, in 2023, bromazolam became the most prevalent designer benzodiazepine detected at Aegis, surpassing 8-aminoclonazepam, and since then it has remained the most prevalent designer benzodiazepine at Aegis, and that's based on annual positivity. Now, the second most prevalent designer benzodiazepine in Q1 was 8-aminoclonazepam, shown in lilac, with nearly 20% of detections. And atizolam and its metabolite alpha hydroxyatizolam, shown in green, were a distant third most prevalent at approximately 3% of detections in Q1. Now, noticeable differences in proportion between Q1 and Q2 include increases in bromazolam and its metabolite, shown in blue, phenazolam, shown in purple, desalkylgidazepam in mint green, and 3-hydroxyphenazepam in yellow, as well as decreases in 8-aminoclonazepam, shown in lilac, and atizolam and its metabolite, shown in green. Now, on the left is the percent change in proportion of designer benzodiazepines from Q1 to Q2, along with the total number of detections in the first half of 2025, shown in parentheses. Now, the largest percent change in proportion of detections from Q1 to Q2 was for 3-hydroxyphenazepam, shown in the pie charts in yellow. It is important to consider that while the percent change is substantial, the number of detections in 2025 is low. In contrast, phenazolam, shown in purple, had a large percent change of 167%, in proportion of detections from Q1 to Q2, and it is the third most prevalent designer benzodiazepine in the first half of 2025. Additionally, the phenazolam metabolite alpha hydroxyphenazolam was added to testing in June of 2025 and had 65 detections in just 1 month. And of these, 45, which makes up 69%, were metabolite only, and that resulted in a total of 148 positive specimens for the first half of 2025. So this means that 30% of the phenazylam positive specimens in the first half of 2025 were identified due to the addition of the alpha hydroxyphenazylam metabolite. Now, small increases in the proportion of bromazolam and its metabolite from Q1 to Q2 were observed, whereas 8-aminoclinazolam in lilac and atizolam and its metabolite in green saw decreases in proportion from Q1 to Q2, ranging from 46 to 70%. I also want to point out 3-hydroxy-des-alkylgadazepam, which is a metabolite of des-alkylgadazepam, shown in mint green, and that was added to testing in June of 2025. So in just 1 month, the number of detections of 3-hydroxy-des-alkylgadazepam tripled the number of des-alkylgadazepam detections for the first half of 2025. Now, all 3-hydroxy-des-alkylgadazepam detections were metabolite only. Thus, it appears the addition of this metabolite will greatly improve the ability to detect des-alkylgadazepam use. This figure shows the proportion of synthetic cannabinoids detected in Q1 and Q2 of 2025. Now, MDMB 4-en pinaca, shown in blue, detected mainly via its butanoic acid, or BA, metabolite, has been the most predominant synthetic cannabinoid detected at Aegis since 2022. In April of 2024, MDMB inaca and its BA metabolite were added to synthetic cannabinoid testing. MDMB inaca, shown in lilac, is a synthetic cannabinoid precursor that can be used to make several different synthetic cannabinoids, including MDMB 4-en pinaca. Now, MDMB inaca, detected mostly as BA metabolite, was often detected with MDMB 4-en pinaca and was the second most prevalent synthetic cannabinoid detected in 2024. Now, in the first quarter of 2025, MDMB 4-en pinaca and MDMB inaca were each almost 1/3 of the synthetic cannabinoid detections. Now, 5-fluoro-MDMB pinaca, largely via its detection of its metabolite M7, shown in green, represented approximately 20% of the positives in Q1. Now, some of the more noticeable changes in proportion between Q1 and Q2 are increases in MDMB 4-en pinaca and decreases in MDMB inaca and 5-fluoro-MDMB pinaca. Shown on the left is the percent change in proportion of synthetic cannabinoids from Q1 to Q2, along with the total number of detections in the first half of 2025 in parentheses. In addition to increases in MDMB 4-en pinaca and BA metabolites shown in the pie charts in blue, increases in 4-fluoro-MDMB butanaca metabolites shown in purple, ADB pinaca PA shown in mint green, and ADB 4-en pinaca shown in yellow were also observed. Now, although the percent change in proportion of ADB 4-en pinaca is substantial, the number of detections in 2025 is very low. In addition to observed decreases in MDMB inaca and 5-fluoro-MDMB pinaca, larger percent decreases were observed for compounds including ADB butanaca and MDMB butanaca and 4-cyanocumulobutanaca. Now, in June of 2025, MDMB 4-en pinaca NBA, a metabolite of MDMB 4-en pinaca, was added to our synthetic cannabinoid testing, and there were 214 MDMB 4-en pinaca specimens in June alone. Now, of these, 46% were positive for both the BA and the MBA metabolites. 41% had only BA metabolite. 6% were positive only for the new NBA metabolite. Another 6% were positive for parent drug and BA metabolite, and 1% were positive for parent drug only. So this figure shows the proportion of synthetic stimulants at Aegis in Q1 and Q2 of 2025. N,N-dimethylpentalone and its metabolite pentalone, shown in lilac, have been the most predominant synthetic stimulants detected at Aegis since 2022. Now, although they remain the most prevalent synthetic stimulants, their positivity declined significantly throughout 2024. Eutalone, shown in green, has been the second most prevalent synthetic stimulant detected at Aegis since it was overtaken by pentalone in 2022. Interestingly, for the first half of 2025, N,N-dimethylpentalone and its metabolite pentalone are for the first time in years not the most prevalent synthetic stimulants detected at Aegis. So N-isopropylbutylone, a novel substituted cathinone, was first identified by the Center for Forensic Science Research and Education in August of 2024, and it was added to synthetic stimulant testing at Aegis in December of 2024. Now, in Q1 of 2025, N-isopropylbutylone, shown in blue, was approximately 27% of the synthetic stimulant detections and rivaled N,N-dimethylpentalone, which had the highest detection at approximately 30%. N,N-dimethylpentalone and pentalone together made up approximately 50% of the synthetic stimulant detections in Q1. Eutalone in green was the next most prevalent at approximately 10%, followed by N-cyclohexylmethanone in purple at approximately 5%, and butalone in hot pink at 2.6%. Notable changes from Q1 to Q2 include the proportion of N-isopropylbutylone almost doubling, whereas N,N-dimethylpentalone and pentalone are seemingly halved. Eutalone is decreased, and the proportion of butalone, shown in hot pink, is significantly increased. So on the left, the percent change in proportion of synthetic stimulants from Q1 to Q2 is shown along with the total number of detections in the first half in parentheses. The proportion of N,N-dimethylpentalone and pentalone detections decreased by 64 and 56% respectively from Q1 to Q2 of 2025, and eutalone decreased by 26%. The proportion of N-isopropylbutylone increased by 92% and went from being approximately 27% of the total number of synthetic stimulant positives in Q1 to being 52% in Q2. The largest percent change increase for synthetic stimulants was for butalone, which went from being 2.6% of the total number of synthetic stimulant positives in Q1 to nearly 11% in Q2. Now, although the percent change in proportion of butalone was substantial, the total number of positives in 2025 was low. Other synthetic stimulants had very low detections in 2025. This figure shows the proportion of hallucinogens and dissociatives detected at Aegis in Q1 and Q2 of 2025. 2,fluoro-deschloroketamine and its metabolite 2,fluoro-deschloronorketamine first appeared in April of 2022. 2,fluoro-deschloronorketamine became the most prevalent hallucinogen dissociative compound detected in 2022, and it remained so throughout 2023 and 2024. Now in Q1, 2,fluoro-deschloronorketamine detections, shown in blue, were approximately 58% of the total hallucinogens and dissociatives detected. The next most prevalent was for 2,fluoro-2-oxo-PCE, shown in lilac at approximately 34%. Now shown in the left is the percent change in proportion of hallucinogens and dissociatives from Q1 to Q2, along with the total number of detections in the first half of 2025. 2,fluoro-deschloronorketamine and 2,fluoro-2-oxo-PCE made up the vast majority of hallucinogen dissociatives detected in the first half of 2025. The percent change in proportion from Q1 to Q2 for each of these compounds was minor, with both showing a slight increase in proportion from Q1 to Q2, which is likely due to the single detections of some hallucinogens and dissociatives in Q1 and not in Q2. So 5-methoxy DMT, shown in orange, is a tryptamine derivative that was added to our hallucinogen dissociative testing in December of 2024. However, the first positive was detected in Q2 of 2025. And now that we've gone through the different classes of NPS, here are the top NPS detected irrespective of class in the first half of 2025. Now the top 3 are the same as the top 3 detected in 2024. There are 4 NPS appearing in the list that were not in the top list detected in 2024. And these include designer opioid orthomethylfentanyl and despropionyl metaparamethylfentanyl, the synthetic cannabinoid 5-fluoro-MDMB pinaca, and emerging adulterant in the illicit drug supply, BTMPS. Designer opioids and NPS other were the most represented NPS classes in the top NPS detected. It should be noted, however, that differences in order rates may impact this data as position in the table is based on the total number of detections. And that concludes our webinar. I'd like to thank you for your attention, but before we wrap up, I want to tell you how to get in touch with us for additional clinical support. The individuals pictured on your screen are my colleagues, the clinical scientist team at Aegis. You are welcome to direct questions to the phone number or email address on your screen. The information covered today is also available in written form, accessible on the Aegis website, www.aegislabs.com. Go to Resources, then Clinical Update. Thank you for joining us today. I hope this has given you additional insight into NPS detection in 2025 at Aegis Sciences Corporation. Have a wonderful day.